Welcome back to Unity using Nottorus, Hexes and Tiles Part 4. Alright, so now that we have the game manager set up, we're going to start setting up the game tiles themselves. So we're going to kind of set the framework for the game tile, make sure you get neighbors, that type of thing. So let's get started. First thing we're going to do is go to the game tile that we created earlier. It's pretty much blank at this point, and we're going to kind of set it up, get some variables set up, get some methods set up, and then basically what we're going to do is find the neighbors of the game tiles themselves. So here we go. So what we're going to do is set up a game start. I'm going to show geometry, which is kind of that center square that pops up. You can turn that on and off. We do find neighbors, of course, and then currently we're going to start with cubes or squares. Then we're going to bake in the hexes later on. So we're also going to need a delayer, a delay timer, because I noticed that as you kind of set up the tiles and they get generated, they don't find the neighbor unless they delay it a little bit. It won't find the neighbor above it because it's already started, and the game manager's cycling through the hexes still, so it hasn't actually created the hex above it. So I'm going to create a little timer here, like 0.2 seconds. I'm sure there's an event system that we probably do, and we may do that some other time or later, but so an event system that says, hey, when the game manager is done, kick off something, do something, right? But for now, we're just gonna have an enumerator here, and it's gonna wait for 2 seconds, and then it's gonna call find neighbors, basically. So we'll set up in a second, but let's go ahead and start with the start method, and we'll get rolling here. Also, just to let you know, I did make the video a little bit faster, so hopefully this just goes a little bit quicker. You kind of see what I'm doing, and you can pause when you need to. So we're going to set up a couple of variables here. A model, which will be the kind of that center game object itself. Going to set up an auto run. We may or may not want it to auto run. We're going to set up show nodes, so we have an option of not showing the nodes, having kind of the not the center square or the links show up, or maybe we do. So kind of a boolean there. Scale time. So we are going to use some lean tweening of those objects. You can use whatever tweening you want, but we can do that scale time here. We're also going to set up a lean tween ease type, and we can do that with lean tween, so we can type in the ease type here and select it. We also going to grab the game board, which is a variable, because that's kind of the parent object. We want to grab that as a variable in here. And then what we're going to also do is create a property variables, just so you can see how that's done. I saw it done in some other tutorials, so I thought I'd kind of show you how it's done here in Nottorus. So what we've done is created kind of an m underscore as a private variable, and then what we do is create a public property. It's gonna be a list of game object list. Everything's gonna be just a list of game objects. So coordinates. It's going to be a vector 2, but the tiles, the neighbor tiles, all that kind of stuff is going to be game objects. At least for now, it seems to make sense. And here's our class property. If it's not showing for some reason, you can go and unhide it down below. Notice I set up both the neighbor tiles and the coordinates. Set up the return types, and then drag them in here, and just like that. You can also set up or turn off the set, because we're only doing the get values here. There we go. So that's just like that. That's how you do a class property. I mean, obviously it'd be more than that, but those will be publicly available, while the m coordinates and m neighbor tiles will be private. First thing we want to do is go ahead and get our game board manager. That's going to have our list of tiles already, right? So we'll just get the list of tiles from the game board manager, basically. We'll grab the game board manager here. try and be a little bit more diligent about putting some notes in here so you can kind of see what's going on as well. So what we're going to do here is, you know, basically if we can't find a game board manager, we're going to do some kind of notification to the console. So if it's null, then we're going to, you know, just send a debug log, basically, right? So just some error coding. So what I'm going to do here is I'm going to set these variables on each of the tile based on what the game manager has set, because I don't really want to go set each individual tile. I guess I can override it later if I wanted to, but for the most part it's going to be similar for every single tile, and I don't want to have to go and set, I mean, I can set the prefab, but I also just want to inherit from the main, you know, game board manager, because I'm lazy and I just want to check mark it in kind of the game manager or in the inspector. So I'm not sure if it's really the right way of doing things, but you know, so I can't find it here because I haven't created them yet. So what we probably need to do is go open game board manager and create some just dumb variables here that are public, and we'll just kind of feed that into each of the tiles. So auto run, boolean. We can put some notes in here, some kind of header, you know, attributes, so they're easy to identify. Kind of OCD about some of that. Makes it easier to read the Nottorus scripting, although it is pretty good in terms of generating the C# code. It's nice to have comments and kind of headers in the inspector as well. So we'll do auto run, show nodes, which will be a boolean as well, and then we'll also do the lean tween type, because you know, those three are going to be passed through. They'll be the same for pretty much all of them. So here, I just double checking. Notice how now that I've modified the game board manager, some of my get set array reset. So I am going to go ahead and go back and just double check and set those again. Starting with 0. Don't forget to do that. I don't know if it's a bug with my version. I'm running the latest version of beta of 2018.3 beta, so I don't know. Anyways, so now that we compiled, we should be able to grab those from the game board manager itself, the auto tile. Sometimes they don't appear. I just close and restart on Nottorus. There they are, right there. So we'll go ahead and we type in game board manager dot or whatever. But since we're pulling off game board manager directly, that's pretty straightforward. Anyways, there we go. Grabbed them. And then we'll just feed them into values into these scripts here. Boom. There it goes. Alright. We're also going to want to grab the model game object. So let's do that here. So this is kind of going to be a weird way of doing it. I basically want a specific way of grabbing in the child object, right? So I'm going to, that slash feeding into the string builder will say, okay, do it from this directory structure downward, or from this game object down. So what we're doing is getting the name of the game object that itself, and we're saying, okay, anything below this object, grab the name of. So that's kind of what we're doing here. And what I'm doing is getting the child, which is the first 0, 1, or the second child of this game object. And then what I should do is grab the node, which is kind of just that small or square black cube that grows from the center of the hex, and it just grows, or center of the cube, it just grows from 0, 0, 0 to whatever size you want. Kind of just gets a visual effect, and you can, you know, not do that, or it's up to you. But this is a way of finding that object under the game object of the tile itself, and doing stuff with it. So that's kind of what these prefabs look like. So we'll just make sure that we do some error checking here to make sure that we can actually find that node game object, right? If we can't, there's probably a problem. So what we're going to do is, if we do find that node, we are going to set it to 0, 0, 0 of the scale of that node sub-game object. So we have the tile, and underneath the tile we have kind of a skirt game object, and we have a node game object. The skirt is kind of just a visual effect around a hex or square, and then the node is that, like I said, that square. So what we're going to do is set that to 0, 0, 0, so it's going to grow from that, once it's found, to a particular size of your choice. So we'll just plug in an auto run here. We have to get position of the current tiles, X and Z, and we're going to feed that into M coordinates. And after that, we're going to go ahead and start our coroutine, which is that IE numerator. And then we're going to wait 2 seconds and then execute find neighbors. So here's our show geometry method. It's really just sizing that center node to a certain size to give it a visual effect. What we can do here is we can just turn, kind of the render on and off, if depending on if we want to show nodes or not. We might be able to do some other stuff in here later, or have it, I don't know, but probably not. But anyways, what we can do is turn on and off the render of the node itself, and then grow it to a particular size. So if show nodes is true, then we'll go ahead and enable it as false. We'll go ahead and disable it. And then I guess we could do a little error checking here again, but that's probably being, I don't know, OCD. Nevertheless, we're checking to make sure that we still have the game object, which we probably don't need to do. unless we're calling from maybe some other method instead of start. Anyways, so, yeah, anyway, I'll just do it anyways. Why not? So at least we have some air checking in there. If we can't find it, we know where to go back and look. So here's where we're going to use some Lean Tween, which is a free asset on the Unity Asset Store. Similar to many other tweening. It's pretty straightforward and simple. I like it. It's fast, whatever. So we'll do this at the ease type. We'll feed the ease type into what we had set on that value earlier. We do need a size, kind of how big we want that node to scale to. So let's create a float, and it's going to be the same for all three, X, Y, and Z. So just feed that into all three of them, and then you can set that size to whatever you want. And the scale time as well. So scale time will maybe be over 1 second, and we'll scale it to maybe 0.25 or something like that. Who knows? We'll have to check, see what looks good. And then we have a choice of kind of ease types if we do it this way. Kind of bounce in or other options. So here we'll go ahead and actually, after our delay in the IEnumerator, we'll go ahead and call the find neighbors method here. So this is how we're going to call the find neighbors method. You need to feed in and return a list of game objects, right? So if we're going to find neighbors, is going to feed in a list of game objects. We'll call that game tiles, and it's going to return, a limited number of found items, right? So, and again, those are going to be game objects as well. What I'll do is just connect that so it'll compile. We can see the code without having an error out on us. But we'll come back and fix that up here momentarily. And there we have find neighbors. We're feeding in the game board tiles list of game objects into find neighbors, and that will produce or return a list of found neighbors, which we will feed into neighbor tiles. There we go. Now I think that pretty much sets almost everything up. We just need to kind of do find neighbors now, and this is gonna be a little complicated because it does use a lambda method. But what we're gonna do is get the directions that we've set up in the game board itself, where we had set up, depending if it's 8 directions or 4 directions if it's a cube, or 6 directions if it's a hex. Here's where we're going to grab those directions, the list of those directions, be it 5, 4, 5, 4, or 6, whatever, list of them, and feed it into this for each loop. And what we're going to need is probably what we found, a found tile, and a list, or what we'll call as neighbor list or end list, temporary game objects. We'll just select new there. This will be game objects as well. So just feed that in here for now. Alright, so here's where it gets complicated. We going to use cycle through the directions, and for each game object we find, we're gonna go to and add it to the find neighbor. So what you do is grab a list item of find. We'll probably need contain and stuff. I should. Oh well, that thing disappears sometimes. I mean, anyways, what we're gonna do is find a game object, and we'll feed that into the found neighbor. Here's where we're gonna use the lambda function. Feed the game tiles that we're feeding into the method itself into the find list, and here's where we plug in the lambda expression, and we needed to get a component of the game tile, because what we're using as game objects, we're actually not using them as game tiles themselves. We're going to be comparing the lists and adding it to the game tile if it's found. So here's where we feed the coordinates in. There, so it looks weird like that, but that's how it sets up. Alright, moving along. That's the Lambda expression. Basically what we're going to do is say if that found neighbor is not in the list already, then add it to the list. That's kind of what this does. So if true, add the game object to the end list find or found neighbor, right? Just like that. And we'll have to set up the if statement to do that. So it's not null, and we're going to put the and here. It's not already in the list. Add it to the list. Here's where we'll use the list contains. Does not contain. There we go. I think that's good. Although I hate these lambdas, it sure looks messy. Maybe like move it around a little bit and widen it out where, I don't know, something like that. That looks a little bit better. I don't know. Alright, we'll save here. So far, so good. Oh, we need to do a return here. There we go. So let's see how it looks here. So far that looks good. What we do is debug here and look at the neighbors. It's showing no neighbors here. That's not good, but let's check that out. There's something not quite right yet. That all looks fine. We need to check some of this stuff. Something's not being fed in from the global list correctly. Let's just double check the prefabs. At least have the prefabs how we want them. I'm confident that this is actually the problem. Alright, still there's no neighbor. That's not quite right. Let's check something out here. Make sure these haven't changed on us. Okay, they haven't. 2, 3, 4, 5, 6, 7. Okay, good. Let's check our tiles out. Let's see what we've done here. There we go. It was supposed to be if true, not if false. That should actually set our variables correctly. That probably will help out quite at that. Alright, we have a few neighbors now. Good. That's what we want to see. So if you cycle through, all of them have a number of different neighbors. And that kind of sets up our, cube or tile neighbor list. So that's awesome. So what we should do is be able to just add the directions into our game manager and kind of, do the hexes very similar. We shouldn't have to really change any more logic in this game tile per se to make this kind of work. It's just really changing the direction, give you a different tile type. So let's set the pointy hex and try it out. Probably won't work because we don't think we set the directions. We did set the directions. Look at that. We just need to set the pointy direction. Is it the flat? Diagonal. Oh, the hex. We needed the hex directions. We never set those up. So let's do that now. And I hate that boolean. I'll fix that while I'm up here. All right. Is diagonal movement. That's not what we want. We're gonna want is pointy hex or not, but we'll change that in a second. So what we're gonna do is actually duplicate this, because if it's pointy hex, we're gonna probably do a certain thing, and if it's a flat hex, we're probably gonna, the direction is gonna be different. So or how you calculate the direction is different. So what we'll do is set up the directions based on if you decide if it's a pointy hex or a flat top hex. Yep. Let's see. We'll put some notes in here so it's easy to identify. This one will be the flat, and this one will be the pointy. So I'm going to grab a couple of these tiles, and there we go. This will be the up and down. This is as if you were looking down on the map, right? So Y is up and negative Y is down. Left, X, right, so just setting up all the directions for the hex based on it being a flat hex. And we might have to come back and fix a couple of these and see what it looks like, see how close do I get to actually success here. It does look like it'll get complicated. A bunch of noodles of code. Alright, tile width, there we go. Tile height. And we just feed all this, all 6 directions. once we've typed all these directions out, double check to make sure they all look good, that's really all we should need to do to make the hexes actually work, if our hex logic is correct. Don't forget to reset the index numbers. Reset to 0. So we need to basically do the same thing with the pointy hex. So what we do is set up the left and right for that. We know that's just a straight left and straight right for a pointy hex. And we just set up all the offsets like we did for the flat hex. Monotony here, making sure that it's correct, making sure we connect things all together, and making sure that the index numbers don't reset. And it does get a little busy on the canvas, of course. Almost done. Hey, the double pace is really starting to annoy me. Alright. Getting the hang of it though. There we go, the last one finally. We'll have to rearrange this so it looks a little bit better. Validate those index numbers. Let's make sure this all looks good. So it looks like it's doing it. We're getting 1. That doesn't quite look correct. So something's a little off. And our directions are not being set correctly. So let's take a peek at that. That's 1 number off. Could be it. That one looks wrong. Let's try that out. Oh yeah, they're diagonally versus pointy. Definitely need to fix that. I never went back and fixed that. Alright. Now let's see how it works. Alright, so that looks good. Setting up the hex looks like they're friends there. They're neighbors. This looks pretty good. Let's try to see what the flat hex looks like. It didn't work right, so what we need to do is figure out why it didn't look right. And what I'm going to do is rearrange the call world coordinates in the game manager. I'm going to rearrange some stuff here because I need to refactor how I did that logic. And basically what I'm going to do is create an additional if statement and move the other if statement as if pointing up. So basically I've copied the if statement of that validation mod section. What I've done is I've moved this is pointy hex if statement up. And then if it is pointy versus if it's not pointy, we're going to do stuff, right? So just move that around. I think that'll fix our logic a little bit. Because what was happening before is that it didn't matter if it was pointy or not, the mod was take effect or not, and kind of mess things up, and we need to change that based on if it's pointy or not, right? That's kind of the logic we have going on here. Is if it's a flat, the logic is a little bit different. We can simplify this by just pointing everything down to the exit world coordinates here, or the return value of the world coordinates. There we go. What we could do is maybe notice a little bit better as well. Maybe put a little bit of a comment section in here. So this section here is for the cube or square, and then we have the is pointy hex or is flat hex section. These to be underneath each other. Down to that, and then it's kind of looking noodly, so I want to move this section under the if statement that it corresponds to, and that's if it's pointy, and this section is it's flat. That's kind of how we'll rearrange the tiles. The tiles in terms of the laying out columns and rows need to be modified based on if they're a pointy or a flat hex. Didn't confuse you too much. We just rearrange them or refactor a little bit of logic there. And that should help us with our actually flat hexes. We're not quite lining up correctly. So this should fix that. And we also have to fix this piece here. It's the tile height, not the tile width in that if mod statement. That's kind of the important piece that we were missing before to offset the tiles correctly on if it's a flat tile. The pointies were fine. So we've set a flat tile here, push play, and see how it looks. No gap, looking good. 2 neighbors, that looks pretty good. There should be 2 neighbors. 4 neighbors, that looks good. Coming along nicely. Something pretty good as well. They all have their neighbors. So what I do is just show you the code for anybody that kind of looks at code to see what it looks like at this point. Might be an opportunity to kind of look through it. Here's the game tile and the code that was created. So what we're going to do next is really this is the piece of the tutorial, and what we're going to do probably the next one is kind of now that we have the neighbors, create the visual effects or lines going from all of the neighboring nodes. But this kind of gives you all of the neighbors, gives you an option of cubes, pointy hexes, flat hexes, and sets the directions for each of those, finds the neighbors. So this is looking pretty good. Here is the code for the game manager itself, or how to set up the tile board. Notice I have the editor debug on. I will turn that off really quick. The code looks a lot better with no debug information in there. Here is that game board manager itself. Here's the directions that we set up. it's pointy or flat or a cube. 4-way directions, 8-way directions, that type of thing. Anyways, appreciate you taking the time. Like it or not. Thanks.